Okay, so in the previous video we talked about how to make an electronic design inside of Fusion and make the PCB design. For now we're going to take it and move it into the mechanical workspace, and we're going to figure out how to program the CNC machine and how to operate all this to make sure that we can actually produce this. So the way we're going to do this is that I have here my PCB design, and now I'm going to click on this view in 3D PCB, and that's going to open up a new file for me up here, a new tab with the design actually here in 3D, and this is what we know as more of Fusion. And this contains now the different traces and ground layers and the sill screens and these 3D packages up here. So the reason why these are square like this is because the buttons that we use doesn't have a 3D package yet. It doesn't really matter for us, we're not going to use it for that much. If we were going to implement this into a mechanical design feature, that might be important for us to know exactly what the size of these buttons are, so we can actually build from it. But for producing the actual PCB, we don't really need them. So what we're going to do here is on the side here, we're going to turn off the packages. And I also want to turn off the copper layer 1. I don't need that. And this is 16, the bottom copper layer. And that's one of the things we want on. We don't need solder masks, and I don't think we need this solder mask as well. Let's just check. No, it doesn't do anything for us. It's not really important. So now what we're going to do is we're going to go into manufacture, the workspace here that we can program the Arduino in, and not the Arduino, the CNC machine. So the first thing we're going to do is we're going to make a setup. And setup is going to default to all the packages and everything, so it's going to make a box that is way too big. So what I'm first of all going to do is I'm going to select model, and then I'm going to select the PCB board in here, and then I also want to make sure to grab the ground plane in here. It's going to highlight that, and then I'm also going to select the individual trace lines here. By just selecting one of them, I'm going to select all of them as they are one body. So the next thing I want to do is I want to make sure that my orientation in here is correct and my starting point is correct. So I can do that under orientation here, and I can collect C and X axes. So I can collect my C axis as being this axis, and the X axis for my machine specifically, I'm going to have this one being the X axis. And now I can see that the C is upside down. I want the C to be pointing upwards. So I can just click on the arrow, and that's going to flip it around, and my X is still in the correct position. And then I'm going to put it to the correct starting point. So I'm going to go for a top view here, and how I want to place in this in my machine is that I want to have it actually, I want it to start from here. So I'm going to put the spindle here and put that as my 0 point, as my work offset. So I'm going to put this stock point here, and you can see that I get a lot of dots around. I'm going to use the top one because I'm going to touch off on the top, and I'm going to have C upwards and like this. One more thing you can maybe see here is if I go into a side view is that there is some stock on top of this and also on the sides, and I actually don't want that. I just want to have full control, and I want it to have the start point exactly at where the intersection of the circle is. So under stock here, you can choose stock offset mode, and you can choose no additional offset. So that's going to put it as the smallest square that it can put around this circle. And I'm going to do OK. So now I want it to come in here and engrave out all these different lines in here. So the things I'm going to use for that is the contour mode. So the 3D contour mode is able to go in and look at the model and figure out where all the contours it should make are going to be. So the first thing we need to do is we need to select a tool. And in here I can select a tool under my libraries. So I have under my library, I have a tapered end mill. There is 0.2 millimeters, and you can see it on the picture over here. So that's the basic tool that we're going to use. I'm just going to click select, and that's going to give me my tool. And then in here I can select some of the parameters that are specific for my machine. So my machine is able to do 2400 rounds per minute. And the feed rate I'm going to use this as is going to be 1,000. I think that's good enough. I can manually override this on my machine, but I found 1,000 you can sometimes, I would even say you can go faster than this. You can go like 1,500 for this type of operation, just because we're removing so little copper. Then the next thing we should use is the geometry in here, and that's, if you don't select anything, it's just going to look at the entire model and it's going to try to do exactly that. So let's just try doing OK, and let's talk about what it actually does and what we don't want it to do and what's not necessary. So doing OK, that will create it over here. And these operations take a little while to actually load, as it has to look at the model and figure out exactly how it's going to start and stop and go and do all these things. So this looks pretty good. That's kind of what I want, but so let's take a simulation look at this. So if I click on this simulation here, I can turn on stock, and that's going to put it into like an arrangement where I can see it as the PCB board, and I can turn off the model if I want to. And then I can click simulate. So what it starts going to do is going to circle around the outside perimeter. I actually don't want that, as I want that to be a cut operation. And then it's going to go in and do some of all the traces. So it does go through them twice, and it does that because it's going to do the trace and the copper layer. So that might add a little bit more extra time to the actual machining time. I find it a little more difficult actually trying to constrain it down, and you're using so much time on making sure that it doesn't do that, that I actually just leave it. It's fine that it runs through the track twice, and I'll just leave it at that. But there is a few fixes for that, but that's a little bit more advanced, so we're not going to go over that. But just note that it is going to go through them twice, just because it's going to do the copper ground plane, and it's going to do the traces individually. So one of the things that I don't want it to do is I don't want it to go inside of these holes. There's no need for this pointed tool to trying to drill out these holes. I'm going to come in here with a drill anyway, and or an end mill, and drill this out anyway. If you're going to manually hand drill this might be a good thing for it to do, but I actually don't need it to do that. So let's just skip all the way to the end, and then that way we can see all the lines that it does. So you can see this is actually what it's going to end up look like. So just going to load. So this is what it's going to look like, and that's okay. That's exactly what I actually want it to look like. So I can turn on the model again. So I don't want it to go into these holes and trying to poke all the way in them. So the way I'm going to constrain that is that I'm going to select heights, and I'm going to select that the height that this is able to go is from the model top and then to an offset of, I don't really know the offsets. I'm going to measure it, how much it actually is for this layer. So I'm going to do I for measure. The shortcut is just to tap the letter I on your keyboard. Then I'm going to select the top layer here and this bottom layer here, and that's going to give me a distance between them. So that's 0.035 that it's set as. So if I just do in the setup here, I can do the height that the bottom height that it's allowed to go to can be the model top -0.05. So giving it a little bit of time to load. There it is. So now you can see that it has this blue circle here that it is going still to make a circle in it, but it's not going to try to plunge in, otherwise the blue circle will be lower down in the hole. So I'm telling it that it's not allowed to go any deeper than that. Okay, so and making sure that it doesn't do this round out here, this blue line, for actually trying to cut a small perimeter from the edge of this one, I'm going to restrict that by selecting geometry, and then I'm going to do a selection, and then I'm going to select this edge right here, and I'm going to do an offset negative, maybe 1 actually. Maybe 2 is too much, just because this line right here is very close. So you see, that got rid of the line in here. So one thing I actually noticed here that mine defaults to not doing a helix. I just want to show you that sometimes you might see red helixes. There is trying to go in and enter some of these positions. So I actually want to make sure that it doesn't do that. I've seen that plenty of times before. So that we want the ramp type to be a plunge operation. And if you hover over this, it's going to show you the different operations here. So plunge being just go straight into the material and go from there. And helix is like this kind of helix spiral operation where it slowly goes in. And this is not really a middle operation we need to do here, so we don't really need this to be anything else than plunge. And then I also turn off lead in and lead outs, just to make sure that it doesn't scratch. Otherwise, it will do a small kind of line. And again, if you hover over it, you can see that the lead-in line is just that it's going to not plunge directly down on the line. It's just going to come in at an angle first of all. But I don't want it to do that. I just want it to plunge directly in. So that should get me all set here. Okay, so now the next step will be to drill out all these holes in here. And the quick way to do it, but also a thing with a little bit of a limitation, is to use the drill operation. It's very smart. So the first thing I'm going to do is I'm going to change tools. So I'm going to change to a 0.8 millimeter end mill here, so really fine one. And I selected it so that I have these presets, so I can do that. It's a full copper layer, like it's a full PCB cut that I'm going to do. I'm going to go through all the way. I'm not just going to cut the PCB copper layer. You can turn this on in your setting previews. So if you want that to be turned on, just go under Preferences, Preview Features, and in here there is one called Tool Library. So that's going to make sure that it has this feature turned on, and you can pre-select these. And I'm going to make our library, these two tools, available for you to download for the PCB. So you can see here the preset is now set, and retract feed is set to 0. Let's just do that as 300. So now under geometry, you can select in here, you can select selected faces. That's going to take a while if there is a lot of holes in this. So what I'm going to do instead is I'm going to do diameter range. So now this is going to look at all the holes and figure out if they are inside the diameter range, and it's going to make it drill. So I'm going to make it from 0 to 2 millimeters. So that's way oversized. And that's going to come in here and drill every individual hole out. You see that it pre-selects all of them. And then I can just do OK. So the problem with this is that it's only able to do an exact drill operation. So even though that the holes in here are actually larger than the diameter of the tool, so you can see here if I click this one, the blue part is the 0.8 millimeter tool that we're going to come in here and drill with. I find this to be okay for most use cases, that you don't have to have a 1 millimeter hole. But just be aware that the drill operation is not going to go down there and contour around to make the hole the perfect size. You can use a different end mill, of course, and make this as 1 millimeter, but it's going to cost this from all holes, especially if you have terminals. They sometimes are a little larger. They might be like 0.5 millimeters, and then you might have to go in there and do it as a contour operation instead. And the way we do that is we select contours onto 2D, but the 2D contours are a little bit more stupid, so they can't tell what to do. They're gonna ask you to click something to actually make that cut. So if I select, for example, the bottom contour here, so I'm just going to select like this bottom piece right here. Then it actually is going to go in and contour specifically that part. Just have to make sure that I set this to a full cut. So I really think the reason why I cannot do that is because the hole is too small. It cannot figure out how to do that, especially if it has a lead-in entry and a lead-out entry. And that's going to cause some problems. So let's see if that fixed it. It did. So you see here, it does like a small circle all the way through. I'm just going to simulate that. So you can see that it comes in and it does like a small circle around and it goes back up. So that's a way to make sure to enlarge in holes that are larger than the diameter of the end mill. So what we're going to do instead is that we're going to make sure that it actually cuts out. So I'm just going to change this one to nothing and to the outer perimeter. And I'm going to select the bottom one because that's going to tell me under heights here that the bottom height is like to selected contours. So I'm going to make sure that I selected the bottom contour. And then my one is defaulting to -1 millimeter. Yours might say 0 here, but remember to set this to a number below just to make sure that you do a full cut through the whole PCB around so you don't end up having it a little stuck. So I choose 1 millimeter. I have wood underneath my CNC, so this is not going to cause any problems, but some people can do a little bit less. They might do like 0.5 or anything else. So let's just, I think 0.5 as well is super fine as well. So one more thing that I just want to tell you, just because I got reminded by that, for making sure that this line is a little lower than the PCB, is to do the same thing for the drill operation. So you can see here that that actually also is going through a little bit more than the hole size actually is. And again, that's height, and just make sure that hole bottom can be set to like -0.5 millimeters, just to make sure that it actually goes all the way through. So let's see the whole operation. So if I click the setup up here and I click simulate and I then run it, we should be able to see that first it comes in with the engraving bits right there. It's going to go through. I'm just going to fast forward through this. So this is the speed control, and down here you have the timeline for where it actually is going to be. So you can see that it's going to skip the operation here and go on to the next operation where it should drill out all the holes. So it does that now, and then it's going to end up doing the contour all the way around. So if I turn off the model, this is exactly what you're going to end up with. So you're going to end up with all these holes and all these lines in all the specific places. So that looks pretty good to me. So now I just want to make sure to export this to a G-code file, and that will be specific for your machine. But what you have to remember to do is click the setup and then click post process, because if you click only on, for example, the contours here, and you click post process, it's only going to do that selected part. So I'm going to make sure to click the setup and then post process, or right click and then do post process. And here the post process that I'm using is a Mark III mill. That's the program that is operated from my machine. And one of the things that I like to turn on is just to make sure that it has the optional stop turned on, I think it is. So just to make sure that my CNC mill is actually stopping between tool changes. So that's Super, I can just do OK, and then I can save it here at my desktop. I can call it PCB mill job version 1. And the super cool part about this is now that I have all this linked up in my file, I might find out that when I'm actually running this, that some of these lines might be too thin, too thick, too close, anything else. The circuit board is incorrect how it's wired or something. And what's beautiful about this is that I can now just go back into the part in here, and I can actually just move some of these components. For example, so I can move this resistor up if it's a little close to the button, and I can correct these lines so that I get a little bit more, so I get them set a little differently. I might want it to look something more like this, for example. It's just an example. If I do save, it's going to tell me that they are out of sync. It's just because so if I sync it from the panel out here instead, this one, and click save, that should cascade all the way through. And if I then go in here and I say view in 3D PCB, that's going to push this design into the 3D workspace. And that's going to, of course, have consequences on the model, how that looks. So if I take a look at the bottom here, see if I can find, so I moved this part right here, and all that updated over here. Sometimes you might get an error. If you get errors for having parts not being updated, you can simply just right-click this part here and click generate, and that's going to regenerate all the operations. If I click yes, I just force it to recalculate all the things that the setup contains. So you're going to see that it's going to start out from the top and calculate if it's still doing the same thing. So you see there, just calculated everything through, and now it's all updated. So that's like the super cool power of doing everything inside the new electronic design of Fusion. Because if we need some corrections, it's easily updated. One thing that you might want to update is the thickness of the copper layer. That might be a little bit different. You might want it to cut a little bit deeper or something, and you can do that by increasing the height of the copper pad here. And that's done actually inside the PCB milling space in here, and it's done inside DRC rules. So in here we have layers, and the layers distance here is set right here. So if I want the thickness that was set to the 0.03 millimeters, if I want that to be any thicker, I can just click on that, and it actually the bottom layer we're working on. So if I want that to be, for example, 0.1 millimeter, so it's going to increase the thickness of the layer. I'm just going to do it on the top as well. And I can then click apply and select, and that's going to increase. Again, I'm going to click push to 3D view. It's going to take a little bit for loading. And you see there I got my arrows actually, so I'm just going to regenerate. So if I can do this one, generate. There we go. So if I now do I for measure, and I click the top, and I click the bottom, like this, we should see that it's now 0.1 millimeter. Okay, that's all I had for you guys today, and see you next time.